of equations. This is really fun. I love doing this stuff. So it is going to be with the 8th grade digits topic 6. Today we're going to actually talk about 3 different lessons in digits, but 2 of them should be, really all of them, are a review from the Kendall Hunt unit that we did earlier in the year. And then the other lessons we'll do in this unit will be the new information. So today should be kind of a review lesson on systems of equations for you. So the title is actually a question: what is a system of linear equations in 2 variables? And then the essential question for today: what is a system of equations and how can I solve a system of equations through inspection and graphing? Hit pause to set up the title and the EQ of your notes. When you're ready to move on, hit play. Alright, first a few definitions that you need to write down. What is a system of linear equations? It is 2 or more linear equations with the same 2 variables that are solved simultaneously, meaning at the same time. What is the solution to a system of linear equations? The solution is any ordered pair, and we know an ordered pair is x and then y. That is the solution of every equation in the system. And what does the solution represent? The solution of a system of linear equations is the point of intersection, and y'all will remember this, I hope, point of intersection of the graphs of the lines defined by the equation. So we did, during our functions unit, learn about point of intersection, which is the solution to the system of linear equations. These were vocabulary terms for you during our functions unit. We're going to take it a bit further in this unit with what we're going to do in the next lessons, but today, basically just a review of what we learned earlier in the year. Okay, so system of linear equations is 2 or more equations that have the same 2 variables, x and y, and the solution is that point where the 2 lines would intersect. Okay, so looking here, we have 1 pencil and 1 marker costs $1.50. 2 pencils and 1 marker cost $2. What is the cost of 1 pencil and 1 marker? If we look at the graphs of the 2 lines, we see that they cross right here. That point is 0.51. That point represents their point of intersection. That would be the point that they have in common. Okay, so that would be the point where P, the pencil, costs 50 cents, and M, the marker, costs $1. A system of linear equations is formed by 2 or more linear equations, so the systems are, and it's going to look like this. You're going to see 2 or maybe more, but usually 2. In this unit you're going to be seeing 2 equations where we see x and y, or, rarely you'll see them use different variables. Usually it's x and y, but you're going to always have the same 2 variables in both of the equations. So this is a system of linear equations, this is a system of linear equations, this is a system of linear equations. Expressions and single equations are not systems. So the following are not systems. This is just a single equation. That is not a system. This is just an expression. That's not a system. Single equation is not a system. And another expression is not a system. Okay, so it has to be, it looks like this. 2 equations would be a system of equations. All right, so take a look and pick which of the following represents a system of linear equations. You should be seeing 2 options that are linear systems of linear equations. It's not the first one. This is just 1 equation. It would be the second one and the third one. These are systems of linear equations. We would have x equals 5 and then y equals x plus 1. Those would have a point of intersection, as would these if we graphed them. All right. Now, you may have some questions on digits like this where they ask, is this a solution of the system of equations? What you would have to do is go to each of the 2 equations and plug in the numbers. So we would plug in 2 for x and 4 for y. Goodness, I'm strangling. Okay, so in this first system of linear equations, I'm going to plug in for the first equation, I'm going to plug in, remember this is x and this is y, so 4 equals 2 times 2, and then I'm going to do the same thing in the second equation, I'll come over here and do that. 4 equals 6 times 2 minus 8. Okay, in the first one, 2 times 2 does equal 4, so that works. In the second one, 6 times 2 is 12. 12 minus 8 is 4. 4 equals 4, so that works as well. So that is an example of a solution of each system of equations. Looking at the second one, I'm going to show you how you would know it would not be. So for the first equation coming down here, I would put 2 minus 4 equals negative 1. What is 2 minus 4? That is negative 2. Okay, does negative 2 equal negative 1? No. Same thing here. I would do 2 times 2 minus 4 equals 1. 2 times 2 is 4. 4 minus 4, does that equal 1? It equals 0. I almost wrote it, so this is not right either. So no. So that's how you can tell one that is a system of linear equations when you plug in the ordered pair and it works. If you plug it in and it doesn't work, then that's not a system of linear equations. That's not a solution to the system of linear equations. So try this one on your own real quick. Hit pause. Work this one in your notes. Is that point 3, negative 4 a solution of the system? Hit pause. So we're plugging in x and then y in the first equation. 3 times 3 plus negative 4 equals 5. 3 times 3 is 9. 9 plus negative 4 does equal 5, so that works. Try it in the second one. So coming over here, I would do 3 minus negative 4. And double negative, we can say plus a positive. 3 plus 4 does equal 7. So yes, this is a solution to the system of equations because it works in both of those equations in the system. Okay, the next thing we need to talk about is estimating solutions of, should not say of twice, it's just of, okay, linear systems by inspection. Now we've already done this. We didn't call it inspection before. You don't need to set up a separate page of notes. This is just going right underneath the notes we just took. So there are 3 different possible outcomes for 2 variable systems of equations. You need to copy this down. What are the possible outcomes for 2 variable systems of equations? When you solve 2 variable systems of linear equations, you are finding intersections of lines we said earlier. Solving a 2 variable system has 3 possible outcomes. This is the first outcome. If it has one solution, the lines intersect at one point. And remember that that means the lines have different slopes. We learned this earlier in the year. You still need to know it now. So I would underline this here. For one solution, the equations have different slopes. That is what is going to make them cross at one point. We practiced, if you remember, think back, we had the graphing calculators and we put the different equations into the graphing calculators to see the point where they would cross. So hit pause and copy this down. On the next slide, we have the other 2 possible outcomes. So when you're ready, flip to the next slide. Okay, if you recall, the second option is no solution. That is when the lines are parallel, because we know parallel lines are never going to cross, so they're not going to have a point of intersection. So no solution is when the lines are parallel. And then I want you to underline, again, I've said this 5,000 times, we've already talked about this year, but this is a review for you. The equations have the same slope, but different y-intercepts. So let's underline that. Same slope, but different y-intercepts. Same slope, different y-intercepts. That's what makes them parallel lines. Because they're the same steepness, they're just on different parts of the graph. The third possibility is infinitely many solutions. Again, we've talked about this before. Earlier in the year, we called this coinciding lines. Coinciding lines. And if you remember, this is when the lines are exactly the same. The equations have the same slope and the same y-intercept because they're the same equation. So we have 2 lines graphed here. Notice in the other ones they had a red line and a blue line. Now we have a purple line because we've actually put them on top of each other. You know, red and blue make purple. So this is two lines graphed and they're on top of each other. It is the same line. There are infinitely many solutions because any single point on this line is a point of intersection. Okay? So, and here are just some examples. Again, we did this earlier in the year. Some examples of systems of equations of each type. And so if you're having a hard time remembering, you may want to jot this down. This is an example of when you have the slopes are same but the y-intercepts are different. That would be parallel lines. Okay, same slope, different y-intercept, parallel lines right here. Here we have different slopes, so those lines are going to intersect. That's one point of intersection, so it has one solution. And then if you remember, when we have two equations where this one has just been multiplied by the same thing for every single part to get this equation, they're really the same equation. If we divided this one by 2, then we would get the first equation. The lines are the same, so that's infinitely many solutions. Okay? So looking at these equations, would this be one solution, no solution, or infinitely many? All right, so looking at this example, we need to first put these equations in slope-intercept form. So let's remember that slope-intercept form, and you may want to write this in your notes since it's been a while, is y equals mx plus b. M is the slope, b is the y-intercept. Okay, so for 2x minus 2y equals 8. To put it in slope-intercept form, I want y by itself on the left, so I'm going to bring the minus 2x over here. Okay, so I would rewrite this. This goes away. I have negative 2y equals, it's going to be minus 2x plus 8. Then I would divide by negative 2 to get just y. Okay, so that cancels out, and then 8 divided by negative 2 is going to be negative 4. So I have y equals x minus 4. That's this equation in slope-intercept form. Looking at the other one, x minus y equals 6. I have to bring x over to the left, so I'm going to subtract x on both sides. My board is not cooperating with me today. So this would be negative x plus 6. That's super. Oh my gosh. Really? There we go. Negative y equals negative x plus 6. Then because the y is negative, I'm going to multiply both sides by negative 1 to get it to be just y. Okay? So that's going to be y equals, just switch the sign, x minus 6. So comparing these two equations, y equals x minus 6, y equals x minus 4, I see that the slopes are both 1, but the y-intercepts are different. Minus 6, minus 4. So which type of system has the same slope but different y-intercepts? It is parallel lines, so there would be no solution. When they have the same slope but different y-intercepts, that is no solution because they're parallel lines. Okay? The very last thing we need to review is something we have also already done, and that is solving by graphing. So in our last functions unit, we learned how to graph an equation, and then you just look at the two lines on the graph and find where they cross, and that is your solution. So quickly jot this down in your notes. How do I determine the solution to a system of linear equations through a graph? It is the point of intersection on a graph, okay? And we see this graph, we see where they're crossing. It would be at the point 4, 5. Remember, x and then y. Okay, so last example here. What is the point, the solution? It's the point of intersection, which is right here, and that point would be, let's see, we go over negative 2, and then down 1, so that would be negative 1. That's our point of intersection. All right, at this point, you should be ready to start on the digits assignments for these 3 digits lessons, 6-1, 6-2, and 6-3.